Welcome back to edupediaword.com, your destination to free online education. In this video, we will be discussing Euclid's Division Lemma. And we will be applying this Euclid's Division Lemma to calculate the HCF of two numbers. Friends, a lemma is an already proven statement, and this statement can be used to prove other statements also. Euclid's division lemma states that given positive integers a and b, there exist unique integers q and r satisfying a equals bq plus r, with the limitations on r as r should be greater than 0 and it should be less than b. R can be 0 in some cases also. Friends, to understand this Euclid's division lemma, let us take an example where a is 50 and b is 7. Friends, the multiples of 7 are 7, 14, 21, 28, 35, 42, 49, 56 and so on. So, with the help of these multiples, 50 can be expressed in a number of ways. That is, 50 can be written as 7 into 1 plus 43. It can also be written as 7 into 2 with the help of second multiple, because 7 into 2 will be 14 plus 36. Similarly, if we use this sixth multiple, we can write 50 as 7 into 6, which will give us 42 plus 8. With the help of succeeding multiple, we can write 50 as 7 into 7, that is 49 plus 1. Friends, in the first three cases, the value of r is greater than 7. But in the fourth case, the value of r is 1, which is less than 7, as 1 is less than 7. So this equation follows the Euclid's division lemma. That is, here if a is 50 and b is this 7, then q is 7 and r is 1. Now if we try to use this multiple to represent 50 in some way, then 50 can be written as 56 minus 6, that is 7 into 8 minus 6, or 7 into 8 plus minus of 6. So clearly here r is negative. Thus, there is a unique equation where r is less than 7, greater than 0. So these limitations are followed only in this equation. So for the given numbers a and b, there exist unique integers q and r satisfying a is equal to bq plus r and these limitations on r. Like if we have the values 550 and 51, then we know that 51 into 10 is 510. So 550 can be written as 51 into 10 plus some value which will be 550 minus 510, that is 40. Again, R is in between 0 and 51. So, according to Euclid Division Lemma, the unique values of Q and R are Q as 10 and R as 40. If we want to apply the same division lemma to the values 220 and 11, for these numbers we know that 11 into 2 is 22, so 11 into 20 will be 220. Thus we can say that 220 is equal to 11 into 20 plus 0. So this is the case when the value of R is 0. Clearly it is also satisfying the foundations on R, that is R should be in between 0 and B, where B here is 11 and A was 220. Friends, in fact this Euclid's division lemma is the fundamental division process that we use in our daily life. That is, if we needed to divide 550 by 51, we will be looking for the closest multiple of 51 which is less than 550, which will be the 10th multiple, that is 510, and the remainder will be 40. If we were to apply the division process that we use generally on this question, then first we will use the second multiple of 11 and on this remainder we will get the value of quotient as 20. Friends, we have studied this Euclid division lemma. Now regarding the applications of this Euclid's division lemma. Friends, the first application of Euclid's division lemma is the calculation of HCF. To calculate HCF, Euclid's division lemma is modified into Euclid's division algorithm. Friends, algorithm is a set of steps to perform a particular procedure. This algorithm says that if we are having two numbers A and B such that A is greater than B, then in the first step apply Euclid's division lemma on A and B. The lemma which we have just discussed. The second step says check for the value of R, because after applying Euclid's division lemma we will get A is equal to BQ plus R and the constraints on R as these values. So check for R. If R is equal to 0, B is the HCF of A and B. And if R is not equal to 0, apply Euclid's division lemma again. On these two values, that is B and R. The third step says continue this process, that is apply again and again Euclid's division lemma till r is equal to 0. That is, till the remainder becomes 0, apply Euclid's division lemma. And when r is equal to 0, the divisor at that stage will be the HCF. Now let us understand this Euclid's division algorithm with the help of an example. Let us take two numbers as 524 and 1726. Now to decide which one should be A and which one should be B, let us check which one is greater. Clearly 1726 is the larger number. Therefore, according to this condition, A should be greater than B. So A, let us take it as 1726 and B as 524 according to our example. The first step says apply Euclid division lemma on A and B. So let us apply on these two numbers the Euclid division lemma. We will get 1726 as 524 into some value, some quotient plus some remainder. So let us divide. Friends, 524 has multiples as 1048, 1572, 2096 and so on. So the third multiple is the closest to this 1726 value, and the remainder will be 154. Thus we get the equation as, let this be equation 1 on applying Euclid division lemma. Now moving on to step 2, let us check for the value of r. Clearly r is 154, which is not equal to 0. The question was 3. So since r is not equal to 0, apply Euclid division lemma again on b and r. So the b was 524. Now to apply on b, that is 524, and on r, that is 154, the Euclid division lemma, let us first check which one should be a and which one should be b. The greater value is 524, so let a be 524 and b be 154. So let us apply this step again, which will give us 524 as some value, that is 154 into some quotient plus some remainder. So regarding the division process, 154 has multiples as 154, 308, 462, 616. So the third multiple will be the required part here, and we will get 62 as the remainder. So again, on applying Euclid's division lemma, we will get 3 into 62. Thus the first equation was this, and let us take this equation as second, that is 524 and is equal to 154 into 3 plus 62 be the second equation. The third step says continue the process till r is equal to 0. That is, continue applying Euclid division lemma till we get r is equal to 0. To apply Euclid division lemma, from the second step, if r was not 0, apply Euclid division lemma on b and r. So b was this value and r is this value. So we need to apply Euclid Division Lemma on 1, 5, 4 and 6, 2. Let A be 154 and B be 62 for applying Euclid Division Lemma, because A should be greater than B. So 154 can be written as 62 into some value plus some remainder. So if we divide 154 by 62, 62 has multiple as 124, 186 and so on. So the second multiple will be the closest and the lesser value, and we will get 30 as remainder. Hence this equation. Again r is not equal to 0 because r is 30. So again applying Euclid Division Lemma, we will get, now we need to apply Euclid Division Lemma on these two values, because these were B and R for this equation. So let A be 62 and B be 30. Thus we will get 62 is equal to 30 into 2, because 30 into 2 is 60 plus 2. Again R is equal to 2, which is not equal to 0. So apply Euclid Division Lemma on these two values. That is, let A is equal to 30 and B is equal to 2. We will get 30 is equal to 15 into 2 plus 0. Here R has become 0. Now, according to the third step, when R is equal to 0, divisor at this stage will be HCF. The divisor at this stage was 2. Because we have divided 30 by 2 to get this quotient. So 15 was quotient and 2 was divisor. Thus the HCF of the given numbers is 2. Hence HCF of these two numbers is 2. So friends, this was Euclid's Division Lemma and its application to calculate HCF. Thanks friends for watching Edupedia Word videos.